certain triangles that are called special right triangles. And they're a little bit more special than other right triangles because they occur often and because they have relationships and ratios amongst their sides that are a really easy pattern to recognize, and we're going to actually memorize the relationships, right? We don't memorize the sine, cosine, tangent of like every single type of angle, but we can memorize the relationships amongst the sides of these two special types of right triangles. And those two triangles are 45, 45, 90 triangles, meaning triangles with a right angle and two 45-degree angles, and 30, 60, 90 triangles. Okay, just take the notes. So for starters, we're going to start with this little activity here. This is a square, and this is an equilateral triangle. We're going to assume each side it has a length of 8 on both of these. For this one, we're going to draw the diagonal, and we want to find the length of this diagonal. I'm going to call it D for diagonal. Okay. What kind of a triangle is this triangle? It's a right triangle. It's also an isosceles triangle, exactly, because if this is a square, two sides of this triangle are the same. How many degrees is this angle and this angle? 45 each, right? Because, well, two reasons, really. With an isosceles triangle, if the two sides are the same, the two angles have to be the same. And since we have a right angle already, we have to take 90 and split it in two. Or you can also think of the fact that, you know, this angle here is a right angle and it's getting cut in half. So we have a 45, 45, 90 triangle, which is one of our special right triangles. What I would like you to do is solve for D. Figure out what the length of D is. How could we do that? It's a right triangle. How could we do it? Yeah. Yes. Good. We could do the Pythagorean theorem. Could we use SOHCAHTOA? Sure, you could. I don't want you to use SOHCAHTOA in this case because I want your answer to be in a simplified radical form. If I ask for an exact answer or a simplified radical form answer, can we use SOHCAHTOA? No, because if you push sine, cosine, or tangent, your calculator automatically gives you a decimal form, right? So it's automatically already an approximation. We want to keep this exact, so simplified radical form. So I would like you to use Pythagorean theorem and find out the length of D and leave your answer in a simplified radical form. All right, so hopefully you got 8 squared plus 8 squared equals D squared. D turns out to be the square root of 128. Remember, we have to simplify the radical. What is a perfect square that goes into 128? 8 goes in. What's a higher one? That's not a perfect square. 64, right? Didn't we just do 64 plus 64, right? This is 64 and 2. So what is the square root of 64? 8. So our final simplified answer should be 8 root 2. Now, could you have used 4? Sure. But it would have just taken you longer to get to this answer. But you still should come out with 8 root 2 as the length of D. Okay, so on this side we have an equilateral triangle. All the sides are 8. Yeah. And get a decimal? Nope. not when the directions were to keep your answer in exact form or leave it as a simplified radical. Right? That's why we've been doing this simplifying radical stuff, because this section, you really need to make sure you know how to simplify those. Okay, so now we can drop this altitude down here. And again, we've split this triangle into two congruent right triangles. We started with an equilateral triangle. How many degrees is this angle? 60 degrees, right? Because in the equilateral triangle that we started with, each angle was 60 degrees. So this is 60 degrees right here. Now, in our half of the equilateral triangle, or the right triangle that we've got right here, how many degrees is this angle? 30. So here is our other special right triangle, a 30, 60, 90 triangle. How long is this side right here? 4, because we split this triangle in half. The whole side was 8. This has to be 4. Okay, I'm going to label this H as if it's the height of this original equilateral triangle. I'd like you to again use Pythagorean theorem. Solve for H. And again, leave it in a simplified radical form. Okay, so you should have 4 squared plus h squared equals 8 squared. It comes out to h is the square root of 48, which simplifies to 4 root 3. So we're going to do the exact same thing again. This time, each side is 2. Okay? A quick Pythagorean theorem here to solve for D. And a quick Pythagorean theorem here to solve for H. Over here, we've got this side is 1. 1 squared plus h squared equals 2 squared. What does h turn out to be? Root 3. Or you could think of it as 1 times the square root of 3. Okay, so let's look at the patterns. When each side was 8, the diagonal was 8 root 2. When each side was 2, the diagonal was 2 root 2. If each side is 25, what do you think the diagonal is going to be? 25 root 2. If each side is 100, what's the diagonal going to be? 100 root 2. So we're talking about diagonal of a square, but remember, we want to think about this as an isosceles right triangle, a 45, 45, 90 triangle. If the two sides of a 45, 45, 90 triangle are 50, then the hypotenuse will be 50 root 2 every single time. Okay? Now, 30, 60, 90 triangles. We thought of this as half of an equilateral triangle. But if we just look at the 30, 60, 90 triangle, hypotenuse is 8. The shorter side was 4. Down here, the hypotenuse was 2. The shorter side was 1. You see that relationship? Hypotenuse is always twice as much as that shorter side. And then the height, so the other leg of this right triangle, is whatever the shorter side is times the square root of 3. So this one was 1 square root of 3, and this one is 4 square root of 3. Okay, so those are the relationships that we basically memorize these relationships. And we use them to solve for missing sides in a triangle. Now, how you memorize them could vary. Different books show it different ways. Our book uses the letter S. So I'm going with S. In a 45, 45, 90 triangle, each side that's across from the 45 degrees, we're going to label it S for side. Okay, S. Now, I like to make my S's with kind of a little squiggle on them because otherwise sometimes they look like 5s, and that can get very confusing, an S and a 5. So I try to do this little squiggle. The hypotenuse then of a 45, 45, 90 triangle is whatever S is times the square root of 2. Every single time. And we just proved it with the Pythagorean theorem, right? Okay. With a 30, 60, 90 triangle, the side across from 30, the smallest angle is always across from the shortest side, right? So the shortest side we're going to call S. The hypotenuse is always double that, 2S. And then the side across from 60, we're going to call it S root 3. Okay, so we've got S is across from the 30. S root 3 is across from the 60, and then the hypotenuse is 2S. So you always have to kind of look at it in reference to what angle is across from it, or opposite from it. Okay, so when we get to a triangle where we're trying to solve for a side, we're going to label the sides S, S, and S root 2 for 45, 45, 90s, and S, 2S, and S root 3 for 30, 60, 90s. So this one, the side across from 45 is S. The side across from the other 45 is also S. And the hypotenuse is S root 2. Down here, across from 30 is S. Across from 60 is S root 3. And the hypotenuse is 2S, double the shortest side. Now, when we memorize these things, there's a couple tricks I like to think of. First of all, I always remember that there's a 2 in my hypotenuse. In both cases, there's a 2. One of them is 2S. The other one is S root 2. So remember that the 2 is always in the hypotenuse. Now, it would be way too easy if it was 45, 45, 90 was S, S, and 2S. That would be too easy, right? So that's not going to happen. It's S, S, and then you have to have that radical involved. S root 2 for 45, 45, 90s. For 30, 60, 90s, we've got S. The hypotenuse is 2S. And then we need a radical on the other side, and this time it's S root 3. You're not going to have two 2's in the same triangle, right? So it's S root 3. So those are just a couple of things to notice when you're kind of memorizing. Okay, there's 4 more triangles on this page. All you need to do here, you're not solving for anything, you're not calculating anything. I just want you to label the sides. S, S, S root 2 for the 45s, and S, 2S, and S root 3 for the 30, 60, 90s. All right, so here's the answers there. Make sure you check carefully you've got everything in the right spots. This is kind of like labeling for trigonometry. We did O, A, and H. Remember how important that was? It's the same thing. All right, any questions there? Okay, so on the next page then, we're going to actually solve for the missing side. I have a process here. I'm going to teach you the process that you can use for every single one of these types of problems, special right problems. Sometimes the process isn't necessary because it's kind of an easy one that they give you. But I'm going to show you the process anyway, and you can use it when you need it and not use it when you don't. But I'm going to show it to you for every single one anyhow, okay? So for this first triangle, well, for all the triangles, my process is to label all of the sides with your S, S, and S root 2, or S2S and S root 3. In this case, we've got a 45-degree angle. So across from 45, we're going to call it S. Across from the other 45, we're going to call it S. across from 90, we're going to call it S root 2. Now, this is one of those cases where it's kind of easy and we might not need this process, but what you then want to do is look at the side where they put a number. They're going to give you one side. Basically, I'm going to have you put an equal sign between what you labeled and what they labeled. So what you wrote and what they wrote are equal to each other. And then you want to solve for S. Now, in this case, it's an easy one. S is 6. Well, now we can just plug that in wherever there's an S on the other sides. So what's X going to be? 6, right? X is just S, so that's 6. And what's Y going to be? Right, well, if it's S root 2 and S is 6, it's going to be 6 root 2. Now, like I said, you probably could have done that without solving for S. But some of these are going to get a little bit more complicated, so bear with me here. This next one is a 30, 60, 90 triangle. So the side across from 30 is going to be 8. We're going to label that S. Side across from 30 is S. Hypotenuse is 2S. Across from 60 is S root 3. Now we go to the side where they gave us a number, and we put an equal sign. So again, basically they've told us what S is. Well, if S is 8 and U is 2S, we're just going to do 2 times 8, which is 16. And then V is S root 3, so we're just going to make it 8 root 3. That make sense? So far, so good? Okay. Why don't you try the next one? Try C on your own. Okay, so the side across from 30 is S. Across from 90 is 2S. Across from 60 is S root 3. So here is the side that they gave you a number on. So we can make it 2S equals 10. This time we have to solve for S. What does S equal? 5. Okay, so if S equals 5, what's Y? 5, and what's X? 5 root 3. Yeah? Okay. Here they give us the S root 2 side is given to us. The other two sides are S. Again, if our equation is S root 2 equals 8 root 2, what's S? 8. You could think of it as dividing by root 2 on both sides, but then they just cancel, right? So S equals 8. So what's U and V? 8. Now, like I said, all of those you probably could have sort of done it in your head, right? Even part C. If you know the hypotenuse is 10, half of it is the other side is 5. And that's 5 root 3. You probably could do it in your head. Sometimes they come out a little bit more complicated. So let's look at E. And sometimes people look at this one and they go, wait, they have the root 2 on the wrong side. It's not on the wrong side. That side is 2 root 2. When we label it S. And S. And the hypotenuse is S root 2. That's okay. That just means that S equals 2 root 2. And if S equals 2 root 2, we have to plug that in everywhere there's an S. So, X equals S root 2. Well, we got to plug this S in where that S is. You guys see that? S root 2. But what's s? S is 2 root 2, so we got to plug that whole value in. So we get 2 root 2 times root 2. You following? Okay, what's root 2 times root 2? And 2 times 2 is, so it turns out that the hypotenuse here is 4. And the two sides are 2 root 2. Yep. Okay, so let's look at F. Side across from 30 is S. Oops, let me change my color here. Side across from 30 is S. Side across from 90 is 2S. Side across from 60 is S root 3. They label that side 18, so we have S root 3 equals 18. We have to solve for S. What are we going to do to both sides to solve for S? Divide by root 3. Cancels here. We get S equals 18 over root 3. What's the matter there? You can't have a radical in the bottom, so we are going to rationalize the denominator. Times root 3 on top and bottom. On the top, we end up with 18 root 3. And on the bottom, what's root 3 times root 3? 3. Remember, the denominator does not just cancel out. Just the radical sign cancels out, right? So we get root 3 times root 3 is 3. Now what's 18 over 3? So S equals 6 root 3. So that means D is 6 root 3. And what's F? 2S, which is 2 times 6 root 3. And what's 2 times 6 root 3? 12 root 3. Good. You guys try G. Okay, so for G, side across from 45 is S. S, hypotenuse is S root 2. What did you get for the value of S? Good. 3 times the square root of 2, because you're going to rationalize the denominator, get 6 root 2 over 2, and that simplifies to, I don't know what I'm writing here, 3 root 2. That means each side is 3 root 2. Okay. Now I just passed out, yes, sorry. So for ones like this, I'm going to do the first one with you. One strategy would be to kind of draw these triangles separately. Somehow, though, you have to realize that this side and this side are the same side, right? Because that's the side that's stuck together in your diagram. But we've got a 60-degree angle here and a 60-degree angle here. So when we label the sides, the side across from 30 is S, side across from 60 is S root 3, side across from 90 is 2S. But on this one, side across from 60 is S root 3, side across from 90 is 2S, side across from 30 is S. So you can see that this side that they share in the top triangle, that side is S root 3. But in the bottom triangle, that side is S, right? So these S's are different values. You can't solve for S in one and think it's the same value in the other one. They're different triangles. So it's a little bit trickier. So, but we have to go to the triangle where they give us a length. So the hypotenuse here is 8. So that means 2s equals 8, so s equals 4. So if s equals 4, then what's this side equal? 4 root 3. Now, what we need to do is transfer that down to the other triangle. Now, this side is 4 root 3. That's our s. You see what happened there? So if s in this case is 4 root 3, right, because that's that side, what's 2s? Good. It's 2 times 4 root 3, which is 8 root 3. Which is what they were asking us to solve for, x, right? But let's just, for the fun of it, let's figure out what this side is too. If s is 4 root 3, then this side becomes 4 root 3 times root 3. What's that? 12. By the way, let's go back up to this triangle. If s is 4, oh yeah, never mind. Okay, if s is 4 and this is 12, if they asked us for this whole side, we could just get 16. What if you end up with what I thought this was going to do? What if you end up with a segment, let's say a side of a triangle, and this is 4 root 3 and this is 12, and I want to know the whole length, and I have to add these together. Can you add these together? No, these are not like terms. So the whole length would have to be written as 4 root 3 plus 12. Can't simplify it any further. Okay? All right, didn't happen in that case, but all right, so I want you to try those other challenge problems. You can work with a partner if you want.